now we're going to take a look at some exponential problems that can only be solved using logs. So again, we need to convert them. So if we look at this first one here, we've got 17 to the x plus 3 power equal to 70. Now, there's no way that you can solve for something in the exponent without using logs. There's no way we can do something with that 3, take the x, the root of it, not going to happen. So we can't solve for x unless we use logs. So we're going to change forms here. We've got log base 17 of 70 is equal to, now logs are equal to exponents, so x plus 3 is our exponent. That's what this is going to be equal to. Now, I don't know about you, but I don't know any exponent on 17 that's going to give me 70. 17 squared is 289, so that's not going to be 70. So we're going to have to use change of base formula. So the base goes on the bottom here, log of 70 divided by log of 17. You're just going to type that in your calculator. You get x plus 3. So what we're going to do there, when we solve that, we'll get 1.4995 is equal to x plus 3. And then we'll subtract the 3 over, leaving us with negative 1.5005 is equal to x. For that one. Our second one we're going to do here is actually going to be a natural log problem. So if we have e to the x minus 4 equal to 17.2, and you're going to learn why these are awesome and really great, because if we change forms here, very similar, we could not solve this without changing forms. But our log base e is really just natural log, so natural log represents log base e of 17.2, and that's equal to our exponent of x minus 4. So when I solve that, I get 2.8449. Look at that, didn't have to use change of base formula, so that's nice. Equal to x minus 4, add the 4 over, so I get 6.8449 is equal to x. Let's take a look at now we're going to take a look at another problem where we've got, let's just look at this one here. All right, so we've got 10 to the x power minus 7 equal to 68. Now, we can't do what we've been doing. We can't just switch forms, because when you switch forms, you need to make sure that you only have that exponential by itself. And right now we have this negative 7 that's not, it doesn't have an exponent. It doesn't have the same base. We can't do anything with it. So we're going to move that 7 over. So we have 10 to the x power is equal to 75. And now here, we actually get to use common log, which is awesome. So just like that e, where we didn't have to use change of base formula, here we're going to have a log. Base 10 is what happens when you don't include a base of 75 equals x. So just a little note here, this is common log. Ooh, that's bright. Which is base 10. All right, so if I solve for log of 75, I get 1.8751. And that's it. That's my answer. That's that problem. All right, we're going to look at one more like this. Just one more. So the last one like this, we take a look at this one. We've got 4 times 8 x minus 4 equals 27. Now here's the deal with this one. You're going to be really tempted, but I do not multiply these. Do not multiply these. That is you making up your own math. Please excuse my dear Aunt Sally, or PEMDAS, or order of operations. It says parentheses exponent. So this is attached, and you cannot just multiply those together because this would need to happen first. So when we solve this, what we have to do is we have to get this 4 to go away from the 8. The 4 has to disappear. Can't be here. So we're going to divide both sides by 4. So we get 8 to the x minus 4 is equal to, let's see, 27 divided by is 6.75. And now this is something that we can change forms with. So if we change forms here, we have log base of 8 of 675 is equal to x minus 4. So we'll solve this. We do need to use change of base formula. So log of 675 over log of 8, because remember the base goes on the bottom. And then we have equal to x minus 4. So we'll solve this. When we solve that, we will get 0.9183 equal to x minus 4. Add the 4 over, 4.9183 is equal to x. And there we go. All right, so make sure that you're getting that exponential term by itself, and then you're switching forms.